Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You can now find us wherever podcasts are distributed. So I am Mary Armour. I'm one of your hosts for this evening, and I'm joined by Professor Jeremy Webb. We are broadcasting live from the Allan Carswell Observatory located at the Kiel campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time or currently 1 a.m. Tuesday Universal time. We are at York U Observatory. We also run in concert with our online public viewing, or as we call it, OPV. This is the feed run by the observatory staff. I am not sure, I don't believe we are doing live observing this evening due to the ongoing cloudy weather, but we will have a great array of archived images that will be shown during the sort of podcast. To navigate to our live show or to find out more about us, please check us out at our website at yorku.ca/science/observatory. And you can follow the link to our online public viewing chat on YouTube. Any questions or comments you may have about past shows or suggestions for future topics, you can please send us an email at observe@yorku.ca. You can also connect with us on Instagram with the handle at YorkU Observatory or on our Facebook page at Allan I Cars Web Op. Okay? All of our programs are free, but if you would like to make a donation, there is a link on our webpage. And you can see the yorku.ca/science/observatory. And we will continue to monitor the chat throughout the podcast for any questions. Okay. Um, so this week, Jeremy and I were going to start out chatting a little bit about, of course, the solstice. This will be our last episode for the 2025 calendar year, as after this, we're kind of going into holidays. So this is the last live podcast we are having. We will still have our regular tour on December 17th, and that will be the final tour for the calendar year. We will also have our online public viewing next Monday, but with a previously recorded episode, but with updated images and hopefully some live viewing. So as I said, of course, the big event at this time of year is the solstice arrives on Sunday, December 21st at 10:03 a.m. Eastern Standard Time. And the solstice is kind of one of those time markers throughout the year. Now, modern times, we don't pay a lot of attention to it, but historically, it's been one of those often key events, especially when you're, a little bit further north or south of the equator. And, we're going into the holiday season, and the truth of the matter is, a lot of these holidays have their origin in solstice festivals, solstice observations, sort of marking this time of year where you get the shortest day length. And then after that, sort of this rebirth theme where the year starts to get longer and longer, even if we're going into usually the coldest time of year in the northern hemisphere. Um, like the whole idea of observing solstices and equinoxes is quite important because, of course, many cultures had some aspect of sun worshiping. And of course, as well, sort of this was a way that you kept time before you had written calendars or things of that nature. So the first monument I'm going to bring up is actually quite an old one. It's not that well known if you don't sort of follow this kind of history of astronomy, and that is of Newgrange. It is a fairly large mound with a tomb type structure inside. It's situated on the River Boyne in Ireland. Um, there are several of this nature in this area, but Newgrange is one of the best known of this type in this area. It's built so that for a couple of days on either of the winter solstice, the sun will shine directly down a passage into the structure. And the length of the structure is about 63 feet. So it's a fairly long tunnel into the structure. It seems to have been some kind of tomb, but there may have been some other um, ritual aspects to it. As they didn't have written language in that time, we don't really know for sure. And just to put in perspective, Newgrange was actually built around 3100 BC. So this is actually earlier than either Stonehenge, which is another very famous monument in this part of the world, or the Great Pyramids. Um, so it is rather a fascinating structure. I don't know, Jeremy, have you ever had a chance to visit any of these kind of places?
I honestly haven't. I mean, I've been to Ireland and the UK, but I never actually. So the Ireland one, I didn't really know about. I didn't know about Newgrange, but I feel like I would have checked that out had I known. But no, I haven't. Have you been to these kind of places before?
No, it's kind of one of those bucket list items.
Yeah.
My kids are now getting old enough that, travel becomes a potential without having to sort of drag the family along, which I'd never really been very fond of.
Yeah.
Um, but these monuments fascinate me because, of course, the other really big one in this part of the world is Stonehenge. And although everybody thinks of Stonehenge and summer solstices and everything, they equally have a winter solstice event. And what's really interesting about both Newgrange and Stonehenge is you can actually get tickets to be at the location in the case of Newgrange, actually in the tomb during these events. And particularly at Newgrange, because it's small, it's a bit of a lottery. So everybody signs up, apparently. And then sort of a lucky 20 people get chosen to actually be there to observe this sort of winter solstice happening. At Stonehenge, it's also sort of a limited crowd. You have to purchase tickets in advance. But during the solstices are sort of the two times of years that people are actually allowed to go in and around the stones because of the rest of the year they're kept away from the monument, right?
This
Um,
this is why I didn't go when the few times I've been to the UK. Everyone's like, "Oh, don't bother going to Stonehenge. They keep you like so far away that you
yeah.
can't really get close or look." But see, I wasn't there during the solstice, and I think maybe if I plan my next visit appropriately, I might try and get tickets to go.
Yeah, because it's like I said, English, if you look at English heritage, if you go to the English heritage website and sort of search up Stonehenge, they actually have all that because normally they just don't want people in there and all over the monument because they've had, vandalism and graffiti and all kinds of that kind of thing in the past. But during the solstices, they do actually allow people into that restricted area. And the same thing, Newgrange, I think they allow access to the tomb more often. But it's just fascinating that you think that, like Newgrange isn't, 5,000 years old. You're talking 31 BC, and they were observing the solstice. I mean, this is not just, you know, a unique thing. If you look around the world, whether you have monuments in Egypt and sort of all over sort of the Mediterranean, through into Asia, through into sort of Central America. The only thing being is it tends to be cultures that are a little bit further away from the equator. If you're too close to the equator, the solstices and the equinoxes don't stand out.
Yeah, right.
So
And
there's definitely sort of a locational thing too. I mean, even here in North America, there are various medicine wheels down in I think it's Arizona or that area. There are these sort of sun daggers where they're located in sort of rock formations so that the sunlight only hits them at the solstice. So this is a very, very common thing to have done. We've totally kind of lost touch with this, but historically, this has been sort of a quite an important event, which I mean, if you look at the list of cultures and festivals that have happened around the solstice over history, it's phenomenally large. I mean, that's probably why Christian Christmas ended up there because they just dropped it in with
yeah,
all
so
the other ones.
yeah, and it requires like dedication. It's not like an eclipse or something that really stands out. Like if you're looking, you can't miss it. Like you really got to like keep track of the night and day and put some effort into figuring out when the solstice is if you don't have state-of-the-art technology.
Yeah, I mean it's a whole observational program, and yet
Yeah.
so many different cultures did it. Partly because that was how they kept time, right? I mean, that
Yeah.
was just you didn't have anything else. You didn't have any other timekeeping records, so most timekeeping was astronomical.
Yeah, I did a bit of a deep dive and I didn't get anywhere, but so maybe you actually know. I was thinking that the winter solstice, or one of the solstice, seems like a real, it makes a lot of sense to make that the start of the new year, to me. And I'm trying to find a good reason why it's not. And
It's
I don't know.
it's
The best thing that came up with was that the Romans don't know how to make calendars, but they do
well,
it.
but they're the one who gave us the Julian calendar. I think what it is if you look at a lot of um, ancient civilizations, they tended to think of the start of year in terms of the agricultural year. So
Hmm.
a lot of them would start their year more around like the spring equinox, because
Okay.
that's when sort of winter was leaving and, planting and stuff was happening. So I think the midwinter one was more, a case of, oh my God, the sun is disappearing and hopefully it still comes back again because it's the
Right.
shortest day of the year, right? So it's a
Yeah.
different kind of attitude, but because so many of them were agrarian, the spring equinox was more the one I think a lot of them focused on for the start of the new year.
Okay.
If you look at some of the calendar keeping, but it's really all over the place, right? For when
Hmm.
they started their calendars, they mark the equinoxes and the solstices, but when they started mark the start of the new year, quote unquote,
Yeah.
varies all over the place.
Yep. That's funny.
Yeah, but so that's kind of like, I mean, historically, that's kind of like where we are with sort of this time of year, like, and the historical backstory is literally thousands of year old, which kind of fascinates me.
Yeah, and I think just the fact that, like you said, so many different cultures had an appreciation and made note of it. It just means that there's that many different views of what it means and what its
Oh
importance
yeah.
can
And it's
be.
interesting because some cultures like the Egyptians or the Romans or stuff left us lots of written records so we can kind of understand what they're doing. And then there's something like Stonehenge where they kind of know who the builders were, sort of.
Hmm.
But the whole sort of process, and Stonehenge is not the only circle in England, it's just by far the most spectacular one.
Hmm.
And without a written language or sort of a culture which it's been passed along, you just really don't know what they were up to with
Yeah,
these
right?
things,
Yeah.
right?
Yeah,
So,
that helps. That helps.
so, but I think in our next thing, we were going a little more modern, and you were looking at the Apollo missions for this sort of week.
Yeah, yeah, so this kind of week was it something like over 53 years ago. The Apollo 17, the very last crewed mission to go to the moon, was running. So they launched December 7th, I think, in 1972 and ran till about December 19th. So about 53 years ago, I think yesterday, is when the crew would have left the moon and started their trip home. And it's kind of a notable mission for two reasons. Like I already said, it was the last crewed mission to the moon. And human beings haven't been back there since. We're scheduled to have a crewed mission orbit the moon in April with a Canadian astronaut on board. And so that'll be really exciting. And then, fingers crossed, everything goes smoothly on that mission. And a year or two later, we'll have new human beings walking on the moon. So that's exciting. But back to Apollo 17, 53 years ago, the second reason it was really cool is because there's the first mission to the moon that had an actual missions specialist on board. Um, so all the missions kind of prior to that, astronauts were selected typically from like pilots and test pilot groups, military personnel, people like that. A little bit because of their piloting skills, but also just because of their you, for lack of a better word, mental strength. They're calm under pressure. They can follow in-depth instructions to the T. And that was kind of the main characteristics of finding an astronaut until Apollo 17, where they actually sent a geologist to the moon. And this was interesting because so astronaut Harrison Schmitt returned to the best moon rock samples to date by far in terms of what we were able to learn from them. So, you know, they can think of the previous astronauts going there. If you don't have that kind of geology background, you're kind of just looking around. Ah, this rock looks cool. This handful of lunar regolith looks cool. But it doesn't necessarily tell you that much about the moon's interior or its history. But you send a geologist there who actually knows what they're looking for. Um, you know, they just Harrison Schmitt returned some great samples, and we learned a lot from the moon, probably more from the moon just from that last round of moon samples than all the ones prior to that. And I think this really kicked off this whole concept and the idea of a payload specialist or a mission specialist, and that continued when the space shuttle missions started in the 80s because those could handle up to 7 astronauts. And if you only need a couple for piloting, and depending on your mission goals, maybe you need one or two to perform a spacewalk, that still leaves a lot of space for someone that's got some specialized training in some sort of field to do some specific experiments. And that's been a very valuable thing that's continued on as human spaceflight has moved forward.
No. I mean, I guess, like the Apollo 17, if you think about it, it's been more than 50 years since we landed people on the moon. Like, what the heck have we been doing since? It's like, if
Right?
you stop and think about it, I mean, it seemed like, okay, we're starting to explore our solar system. And then they pulled back, like they switched all their energy to the space shuttle program, which had its benefits. But there were a lot of people, I think, who were very disappointed in that because it's like, well, you've brought us everything back to Earth orbit and sort of anything beyond Earth. And yeah, there were the Viking missions and there was Magellan, but other than that, they really pulled back after that for a lot of the stuff, outside of Earth orbit. So it was almost like, like we've expended all our energy and now we're just gonna, cut back
Yeah, they
after this one.
really
Because I think there were more Apollos planned originally, weren't there?
There was a lot more, and a lot of it comes with, you know, losing government backing and losing public interest a little bit, right? There's this whole space race, trying to get to the moon, you know, doing your flexing your political muscles, saying, you know, um, we're better than this country or this political ideal, and then once NASA actually got to the moon, and you know they had a couple missions there, they really lost public interest, it seemed. And then with the government being like, all right, we made it to the moon, let's move on to something else, NASA's budget shrank by like a factor of 10,
Oh
um,
yeah.
moving on from Apollo 11 and afterwards. So they kind of had to consolidate resources and say, well, what can we do next? And so to develop a whole new shuttle program with the focus on reusability and affordability. Not that it quite ended up being that.
No, I don't think you could call the shuttle program affordable at
No,
any
no, that was the
no.
original goal. But yeah, so without that public and government backing, I think NASA really had to refocus. And yeah, which was a shame because it seemed like a big step back in a way.
Yeah. I remember
Obviously, we
just
made steps forward with space stations and space habitats, but
yeah.
exploration wise, it was a step back.
Yeah, and it's kind of funny, like if you put it too in this in the historical context, this is also like, towards the end of the Vietnam War where America was getting tired of some of that kind of stuff. And you also had the oil crisis come up in the 70s and all the economic problems were hitting. And
Mhm.
you had, of course, Richard Nixon and all his, nonsense going on. And I think those all are going to play into it, right? Um, it was just a case of, like, we just can't afford to do this anymore on top of everything else. So it was really kind of sad that they, and some people think they made the wrong decision with going with the space shuttle because essentially what have they gotten out of it? Like you had these four really expensive shuttles that probably did some great science, but what's the follow on,
Yeah, and I think that the Russians really showed, like, you know, just staying with the Soyuz, the more missions you do, the cheaper it gets, right? Essentially, you have this pipeline for building a spacecraft, and every Soyuz mission just gets cheaper and cheaper as you create it, and they're still able to accomplish quite a bit. So, you know, I mean, you have Hubble, we have repair missions to Hubble. There's, the creation of the building of the ISS was helped by the space shuttle, but I think if you could go back and do it again, a lot of people would do things differently.
Do things a bit differently. Yeah, it's because it's like I said, like the Russians did like as much. I mean, Mir was really the real predecessor to the
Yeah.
ISS because a lot of the technology and the experience that came out of that is really what got that made that possible. People don't like to admit it.
Yeah, but I mean, it was a modular space station,
Yeah.
right? In a similar way that ISS was, and yeah, so it just showed that it was doable with cheaper technology and didn't require a complete overhaul. And even as we go back to the moon and maybe to Mars in the future, we're back to these little spacecraft on the front of a rocket, on the tip of a rocket, right? Where
It's like
they
you're
abandoned this idea of a reusable orbiter.
yeah, it's like I said, where it's kind of sad, like you've come a full circle and you're back to the Saturn rockets. It's oh
Yeah,
God.
but then the advances there have been, well, now the rockets are reusable, right?
Yeah,
And so they've found ways to make it cheaper without making the actual spacecraft the thing that you keep reusing.
quite so expensive. Yeah.
Yeah. And there's always going to be that argument of why are we spending money to go to space when there's problems on our own planet that could use some financial help too. And that's always going to ebb and flow with
But that
what's
that
going
that
on.
argument can be used about any kind of scientific research. And yet in the end, there are so many spin-offs, whether it's Velcro or Tang or all
Camera
kinds
phones.
of other things, yeah, that come out of it that, you people don't understand that like pure science has so many spin-offs and so much innovation that
Yeah, that's what
benefit
I
in
tell
the
my
end.
students. It drives technology forward, right? Like if it wasn't for the Hubble Space Telescope, we wouldn't have CCD cameras on our phone. We would just have, instant camera development from film or something.
Polaroids.
Polaroids. Well, yeah, I read somewhere that like a lot of these camera companies kind of had digital cameras well before NASA, but they didn't want to release it because it would kill their film business.
Yeah.
So it wasn't until it was developed for scientific reasons and released to the public that it was
Yeah. It's
cost
like I think you
effective.
had them in cash registers for scanners before you had them for the public that easily.
Right? Yeah.
Yeah, think
But
about it.
but yeah, no, like you said, all those spin-offs, it drives technology, everything forward. And then yeah, there's always just that ebb and flow of where to put the money and when.
Yeah. So. Yeah, so I had one space mission that landed in 1970, so a couple of years earlier, and this was actually going back. It was the Soviets, and although it's not well acknowledged, they were actually the first one to land on another planetary body other than the moon. So Venera 7 uh, descended and landed on December 15th, 1970. Now, originally they weren't sure what had happened because it seemed like the landing was not a great success. It landed, but it seemed to have gone sort of sideways. And at first they didn't know what had happened. And then I don't know, it was a few days or whatever later, a radio astronomer actually picked up the weak signals from the probe because it had transmitted for about an hour. And so they found the signal in the radio data and
Hmm.
they actually got quite a bit of data back about Venus. But this was like the first planetary body we landed on. I mean, people think about the Viking missions or something like that, but Venera was a few years earlier, and it was just the first of a number of landers that the Soviets
They
put
were they
on
were
surface.
committed. They were committed to studying Venus. My goodness, they had so many missions.
I know.
Um,
I don't know why they focused on Venus. Maybe because the Americans were focusing more on Mars. Um, and the Americans had sort of won the first landing on the moon, so they figured they had to do something to get a little bit of their
yeah, but I think
status back. And landing on Venus is not an easy task, right? I
no,
mean,
it's got such a dense, thick atmosphere. It is crazy hot. I mean, you really you need a bit of luck, even if you plan it all down to a T.
yeah. Yeah, and seven had not enough luck that it landed, but not enough luck that it landed well. But then a couple of their later ones actually landed and took pictures and survived for up to several hours in those kind of pretty intense
Very dense. Yeah.
conditions. So it's just fascinating that, 1970s technology was landing on these planets, and yet we haven't put down a lander. I think the last Venera landed in the 80s sometime, and we haven't put down a lander on it since. It's sort of like, now I know you can do a lot with satellites and it's a lot cheaper, but it's sort of like, okay, so why are we, not pursuing some of this?
Yeah, and
Just,
it was only 8 years before that that we had NASA had the first robotic mission to Venus, which was I think the first robotic mission to any planet. And
yeah.
it just seemed like all these missions were like increasing in complexity and achievements at such a fast rate, and then there's just this stall of, yeah, we're just gonna hang out in low Earth orbit and send the odd thing to another planet, but it's not gonna be too complex.
I know it was really a strange pullback if you think about it. It's almost like I think the political situation and everything else caught up with them,
Hmm,
and they decided, no, we're just going to do something different for a while. Like
right?
space, it's not a space race anymore. We've proved our point. Let's move on, right?
Yeah.
And that wasn't unique to the US. Like I said, it happened with the Soviets too, and then they focused on the Soyuz and the Mir. So
Yeah.
yeah, I don't understand why the sort of solar system exploration got lost. But I still remember one quote from Carl Sagan about that, and this was sometime in the 1970s, that you could have run a tour of the solar system, and not with landers, but with just, flyby spacecraft on the cost overruns of the Defense Department for a single year in the US in that time period.
Oh my
So
goodness.
it's just, now I don't know how accurate his numbers are. I suspect he was pretty close,
Hmm.
but that's also the middle, of course, of the Cold War and sort of the whole, race for the biggest and best nukes and everything else. So you can understand how it's like you're spending all this money on something that's not going to accomplish anything. Where, if you went into space, you'd get all this other innovation and knowledge. But yeah.
Yeah, well, I remember someone, a colleague of mine that worked for NASA for a while, with the Hubble Space Telescope was contacted by a military personnel, and then they brought him in and they said, here we have these two extra spy satellites that we haven't launched, that we don't really need. And they were effectively Hubble equivalent in terms of cost and capabilities. They were just designed to look at Earth versus looking to outer space. And they're just kind of like, can you do anything with these? Do you want them? And so that's an example of two, Hubble was 20 years in the making, a huge fraction of NASA's budget. And then here's the Department of Defense with kind of two backups that were
Like, would you like
equally,
these? We're not using them right
yeah, we're
now.
not using
Like,
them. We don't need them.
seriously?
Yeah, yeah,
Yeah,
yeah,
I'm
yeah.
like,
And I was just, he told me this story and I was like, oh my goodness, like that they're just sitting there and they were the backups in case the first one, the one they launched, didn't work. Just like, oh my goodness.
I mean, I understand like having backup satellites and stuff, but you're like, oh my God, like the wasted money if they're just sitting somewhere
Right? Yeah.
not doing
That's,
anything, like,
yeah.
seriously?
Seriously.
But it's like I said, you wonder sometimes how much money all these massive nukes they built and sat in their silos, and God only knows if half of them would even work anymore,
Yeah,
if they
right.
ever would in the first place.
Yeah. Yeah. If they even worked in the first place. Yeah. So no, I'm sure that's a good way of putting it that I'm gonna remember that Sagan quote that you could pay for it all with the overages.
Yeah, just the cost, not even the cost overruns of all
Cost
these
overruns.
military projects. It's just it just it kind of boggles your mind, like when you think of, how scientists are sometimes scrapping for like funding and all the, begging and contortions and everything you go through, and yet, sometimes the military in the States, they just piss money away. You think, my God, like, why? Why can't you
Why?
give your
Just
money?
give us a fraction of that and we
It
could
was a
you know.
fraction of that. It's like I still remember, like reading about when they canceled, because originally SETI was a NASA program.
Hmm.
Um and Congress got all up in arms about, oh, why are we supporting this ridiculous like search for extraterrestrial life? And you can see the point a little, but the technology that came out of it and the radio searches and everything had a lot of other benefits. And they canceled it because it was too expensive. And even at the time, it was less than 1% of NASA's budget.
right?
But the politicians got a hold of it and it's like, why are we wasting money doing this? It's just, yeah, it's kind of sad when you think about.
Now it's all like almost crowdsourced and public funding. I think you can like register your computer or something to like process data for them if you want. Maybe that was like a few years
Oh
ago.
yeah.
It's just you can,
Yeah. Oh, I still remember that SETI at home program. I
yeah, the
know I
study at home
ran it as a
program.
screensaver.
So and no, and you know, most scientists, not just astronomy, but in any field, you're really pooling together resources. You're becoming innovative to create cost-effective things, which helps in some way. It's cool to have those innovations, but at the same time, you could do things a lot easier for just a little bit more money.
Yeah. I mean,
Yeah.
we'll never have as much money as we like, but
No, no, yeah, no one ever does, but you
no one
could
ever does.
a little bit more would help.
Yeah. So we've reached about the midpoint. So you are listening to the York Universe, our last broadcast for 2025. We are broadcasting live for the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please check out our website at yorku.ca/science/observatory to join the chat. And if you have any questions or want to see more of our content, it is all available through our webpage. This podcast and others are distributed any number of places, including YouTube, where we have the uh, live, sort of our online viewing, mainly archival images tonight that runs in concert with this podcast. Tonight, you are listening to myself, Mary Helen Armour, and my co-host, Jeremy Webb. So we've just been discussing some historical items, but now we're going to move on into sort of the current astronomy news. Again, just a reminder, we do have a tour this Wednesday, December 17th. Um, and after that, we will be closed, but resuming our operations for tours on Wednesday, January the 14th. So in the news in history, one story that's probably popped up in a number of our recent podcasts um, is, of course, the Comet 31 Atlas. And it rounded the sun not that long ago, and it actually makes its closest approach to Earth on December 19th. It's still pretty far away. It's still about 1.8 AU away, so it's still quite a distance away, probably still not visible to the naked eye. And at this time of year, of course, the viewing is, a little bit sketchy. I think I've seen stars once in the last 2 weeks from where I am. But Atlas, if you have sort of the observing capability, should be visible sort of middle of the night right now. It should possibly be visible. I've seen some great pictures of it. I have not been able to locate it at all myself. Of course, the weather has not helped. Um, I haven't even had much of a chance because, of course, the other big thing going on right now are the Geminids. And even though I was out last night for a while where it was kind of clear for a bit, I didn't see anything. I was slightly disappointed. Um, I don't know if you had any better luck with observing in recent weeks, Jeremy.
I'm what you would call a summer astronomer. When the weather's most of my work is theoretical and I'm plug away on my computer, but when the weather's nice and warm, I will go and observe with my telescope or the odd observatory night here on campus. But once it gets cold, I lose my motivation. But I mean, yeah, I mean possibly the third interstellar comet ever is pretty exciting and it would be nice to be able to see it with my own eyes, but no, I haven't been able to get a crack at it.
Yeah. I mean, I'm lucky up where I am because I'm just on sort of north of Barrie. So I have not great dark skies, but certainly a lot better than Toronto. And at this time of year when the skies are clear, um, you can, like bundle up and stand on the back porch and there's, the seeing's pretty good. The only catch is at this time of year is I'm not that far from a couple of the ski places up here when they turn on their lighting
Oh
system.
no.
There are places on the horizon. I was like, okay, we can't see much there. But the cool thing is sometimes if you go skiing at this time of year and you go night skiing, if you're at the top of the hill, there are the odd dark patch
Yeah.
where you can actually see quite well because you're kind of up, and the horizon is mostly below you. So
Mm.
you can get you can see some things really well sometimes on the ski hills.
That's pretty. I can imagine going down a ski hill with the meteor shower going overhead. That sounds pretty fun.
Yeah.
Or dangerous if you're looking up while you're shooting looking down.
It's usually at the top of the hill,
Yeah.
right? Because then
Yeah.
most of the lights are pointed down.
Right.
So it's actually not too bad. And there are usually some spots at the top of the hill that are a little darker. So you can see in some, depending on the geometry of the hill, but you can see some stuff. So
That's cool.
especially like some of the planets, and you can get some really pretty views of the moon at this
That's
time
nice.
of year.
You're
So
making an argument for a little bit of a pop-up astronomy at the top of a ski hill. You'd probably get a lot of people just come take a quick look while before they go down
yeah,
the.
of course, getting the EV scope up the lift.
Well, I'm sure
And
you
then
could
even
take a
worse, having to
snowmobile out.
ski down the hill with it.
Maybe just rent a snowmobile for that part, but
Yeah, I could probably con the ski patrol into taking it up for you. You
yeah,
had like a viewing night. Although I don't know, yeah. It's like I said, you have to find a bit of a darker spot on the hill. So,
yeah, you really would. But
but
another interesting thing about Comet 31 Atlas has been it's been an interesting example of science communication. I feel like it pops up in the headlines a lot, but for a wide array of reasons.
some good, no, some, yeah, I really wish you wouldn't talk about that, but okay.
Well, we don't have to get into it, but it's
Yeah,
just it's been interesting the different theories of whether it's artificial, whether it's natural, and all the reasons why. And I only bring it up because my students are asking me a lot about it this semester.
yeah.
Uh,
And
and
every time one of these pops by lately, I'm like, okay, I gotta drag out my copy of Rendezvous with Rama again. Although now I have it in ebook.
yeah.
Um, but yeah, it's like, okay, maybe Arthur C. Clarke was pretty good.
Yeah. Well, so the thing I stress to my students is that if it's someone who says absolutely it's artificial, it's aliens, and there's no chance it's something else, I would worry about that person. And I think if it's someone saying it's completely 100% natural, zero chance it's aliens, I'd worry about that too. I think you want to find the people that are acknowledging all sides of the coin and presenting what they feel like is the most likely
Yeah.
based on their observations.
Like I find it fascinating that, it's just in the last, what is it, 10 years, that we found three of these extraterrestrials. So you wonder how many of them have come through the solar system. We just didn't recognize what they were
Yeah, right.
prior to this, right? And you wonder, like, especially with the Vera Rubin, how many of these things we might find coming up
Yeah.
over the next decade. It's the same thing as extrasolar planets. Oh, you had one, and then you had another one, and then maybe you had a dozen, and then all of a sudden it's like bang, you've got thousands of them when they put the Kepler mission up. And it's like, oh,
Yeah, right. Well, I wonder if anyone's been doing some deep dives into some like ancient comet tracking. And I wonder if there's enough information there to ballpark an orbital trajectory. Probably not, but it would be amazing
probably
if
not.
someone could say if someone had that information, like, oh, 1 week later it was complete other opposite side of the sky, and you could really
Yeah.
ballpark
I
an
mean,
orbit. It's wishful thinking, but it'd be
yeah, probably going back to like early 18th century, like 1700s, when you had the Paris and Greenwich observatories going. There may be the odd comet track in there or something that was observed that maybe wasn't well recognized at the time.
yeah,
That may have, that if someone did a deep dive, they may actually be able to track it because they might have enough observations to tell what it was.
yeah,
Um, and you go back in some of these historical ones, and sometimes you find some interesting things.
right,
They
yeah.
actually they actually figured that Galileo, with one of his scopes, may have tagged Neptune and observed it for a couple of nights and then lost it and never
Oh,
recognized what it was. So,
interesting. Interesting. Cool. And I know they found a few supernovae remnants just based on historical accounts of where the star was in the sky when it like first appeared. So that's been kind of interesting too.
so
But yeah, so besides 31 Atlas, you mentioned exoplanets, Mary, and there was some recent exoplanet news. So there was this rocky planet. It was found by the TESS telescope, so it has some TESS internal naming nomenclature. Doesn't have a fun name or anything. But it's a rocky planet. It orbits a star that's about a little over 280 light years away from us. But it's interesting for a few reasons. It's a bit bigger than Earth, about 1.5 times the size of our planet. So it's loosely referred to as a super Earth. But it hangs out really close to its host star. It only takes about 10 hours to go around it, which means it's very close. That star is it's a little dimmer than our sun though, so it's not as hot as if you were orbiting that close to our sun, but it's still a hot place. And its star's very old, which is one interesting about it. So the host star is about 10 gig years old. So this is maybe 3, 4 billion years after the Big Bang. So that's cool just to know that rocky planets like our own were able to form that quickly. You didn't have to wait 10 gig years like we did for the Earth to form to get a rocky planet. It seems up to or around 3 or 4 billion years after the Big Bang, you could start forming rocky planets, which is cool. And so you have this it's really hot, like I said, surface temperatures of around 2,500 degree Kelvin, which means people think it's probably some sort of lava world, or at least half of it's a lava world. And the reason I say half is it's because this planet is tidally locked, which is the tidally locked is what we say when like the moon is tidally locked to the Earth. The same side of that planet is always facing the host star. So one side of the planet's permanently in daytime, and one side is permanently in night. So the daytime, the one that's getting all that solar heat, that side's likely just pure magma ocean. While the other side, it might be cold enough for rock, for it to have solid rock. And so this planet's been known for a while, but what's been recently discovered about it with some JWST data is when they measured the planet's dayside temperature, it was actually cooler than expected. Comparing that to models of just a rocky rock only surface or even this magma ocean. And the reason they concluded in this study that it was cooler than expected is that it must have an atmosphere, and it must be an atmosphere capable of absorbing heat. That's why the planet appears cooler, the exoplanet appears cooler than we expect. And so if it's absorbing heat, it likely has things called volatiles, things that can easily vaporize. So something like water vapor might be there. Absorbing heat in this exoplanet's atmosphere. Um, and it's surprising for one big reason being it's so close to its host star. You naively would think that solar radiation, solar wind from that host star would have long stripped that planet's atmosphere. So the fact that it has one and it's so close to its host star and it's rocky. So by rocky, I just mean it's a terrestrial planet like Earth. It's not like a Jovian planet like Jupiter or Saturn. Um, and we haven't been able to really confirm atmospheres around rocky exoplanets yet. So a lot of interesting discoveries all in one, and then the proposed model for this world. So how you get a lava world orbiting a star on a close orbit with an atmosphere is the authors called it a wet lava ball. So you have this atmosphere that is escaping into space as you would expect due to interactions between the atmosphere and that star's solar wind, but it's constantly being replenished by gas from the magma ocean below. Now that's just a model. That's a bit of speculation, but it's how the astronomers, how the authors of this paper think uh, that kind of a planet could withhold its atmosphere for 10 billion years.
the other interesting thing is this is sort of, the geological end of it is if this star is quite old, this planet could, well, obviously this planet probably did not form that close. We don't think planets form that close.
Hmm.
Um, but you wonder if it even hasn't been that long since it spiraled in, because if it's still outgassing, I mean, there's only going to be so much water within a mantle and a crust. And if it's been exposed to this kind of heat for, any length of time, at what point have you outgassed most of those volatiles? Or what other weird chemistry is going on within that lava that's, releasing other gases? But even so, there has to be a time limit on this, or you would have evaporated the whole planet away.
Right? Yeah,
So,
exactly. So,
so you,
yeah.
you kind of wonder if they're going to try and get any kind of like age estimate on this planet, like based on if you're evaporating it away and creating an atmosphere, like and this kind of thing. How long can the planet actually last? Or is this the remnant of one of those hot Jupiters where all the outside stuff's been blasted off and now you're just, evaporating whatever's left of the core?
Yeah, I mean that's an awesome thing, which I mean maybe it was deeper in the paper that I didn't come across because yeah, it could just be a Jovian, a hot Jupiter's remnant core. They did mention it's quite dense. It's quite a bit denser than Earth. Um, so maybe that
Yeah.
would be a really cool idea.
Yeah, which would
Uh,
suggest if there was a lighter crust at one point, it's been evaporated off. Right?
yeah,
Just from a strictly geological point of view, I'm thinking, I'm like, well, what happens with magma and stuff like that? You're going to slowly, your crust is going to be your less dense, but if you slowly evaporate it away, you just have the more dense interior left. So you wonder how big it started
yeah,
to
that's
get to this
cool.
point?
Yeah, and I can't say I have read. I mean, this is more your realm of expertise than mine, but like, have people even modeled that? Jovian planets getting stripped down to their core and then
Well, I
being
remember it
left.
was speculated about when they were finding the first hot Jupiters, because it's like, wait a minute, these things have got to be losing their atmosphere at some point.
Yeah,
They've got to, like this has all got to be blown away by solar wind and everything else. So, is this one of those examples of, especially because the star is so old, of, okay, this is what happens when one of them's been,
yeah,
melted down. I don't know what you call it, melted down, outgassed out, like, whatever you want to call it. I mean, it would be some interesting speculation to see if this is potentially what has happened here. I don't know how you'd prove it. Um,
yeah. I don't know either, but I mean, if you could get maybe if you could get some like a proper spectrum of what this atmosphere is, right? Because like I mean, what like Jupiter like if you could really figure out that it's some hydrocarbon and some hydrogen. I don't know. Even then, it'd be guessing, but you'd
yeah.
probably have to get a good chemical composition of
Yeah,
what's
I think I said, well, I
there.
mean, if it's hot enough that the one side should be lava, you should get some rock evaporating on some level.
Yeah,
You should have some traces in the atmosphere of this kind of activity that you
yeah,
could trace. But it'd be interesting to have a deeper look at
yeah.
it for
And
that kind of thing.
it's so hard to get, especially for smaller planets, exoplanet atmosphere compositions. You
Yeah,
just need a lot of data. Right now, we just have it for a handful of large planets,
yeah,
Jovian planets. So you'd have to dedicate a lot of JWST time to get a chemical composition of this thing.
yeah. Which might be challenging to get.
It might be challenging and yeah, but we just
Eventually.
need the backup. You need the backup JWST that somebody made to send up there.
They've got it sitting in a military warehouse
Right?
somewhere
Yeah.
somewhere in the middle of nowhere.
Somewhere in the middle of nowhere, just in a bunker somewhere. Let's just send that up and point it at this thing for a few years.
But I guess what's so fascinating about some of these planetary discoveries is they just keep finding more and more weird and wonderful variations on what a planet is and how it can behave. I mean, I remember like when they were first discovering exoplanets, they're like, how the hell can we have a Jupiter that goes around its like primary the space of days or weeks? Like, how the heck did it even get there? Because there's
Right?
no way it could form there. Right. So when they were first finding this, like, what the heck is going on? This was not what we were expecting at all.
Yeah, not at
So,
all. And we're not really finding, I mean, so observational bias is part of it, but we're not really finding a bunch of planetary systems out there that mirror our own. There's so many unique combinations of planet sizes and masses and distributions. It's been really neat to witness.
Sci-fi will need a rewrite because if you go back, of course, to the sci-fi and sort of the ideas, it's all like whenever they talk about exploring new solar systems, they always are sort of this, 8 to 10 planet thing that's Earth-like with a couple of hot ones too close, and then, a couple of habitable ones, and then a bunch of giants outside, maybe asteroid belts. And if you sort of read the sci-fi, they all have this kind of impression that all the solar systems look like ours, and yet when you look at the actual results that are coming in, it's like, nope, that's not quite how it works.
No, right? Yeah, yeah. No, it's all the yeah, rewriting the fiction and the nonfiction books are should be need rewriting.
So, so it's like I said, you wonder what kind of sci-fi will come out that tries to take some of this into account.
Yeah, yeah, right.
So,
We've been just seeing some of the stuff in the last 10 or 15 years that bring in like, black hole physics and time dilation and stuff like that. Those aren't things that sci-fi would have included 50 years ago. So it's been fun to see that that's the fiction side try to catch up or try to update itself with what we're learning.
uh, yeah, I think you had another one that goes even farther afield with
Yeah.
black holes.
Yeah, we're
Speaking
going
of
from
which,
one extreme to another. Yeah, there was a study very recently just published about possibly the first detection ever of a runaway supermassive black hole. So runaway means it's just kind of flying through a galaxy on its own. It's a supermassive black hole means it's millions or billions times the mass of our star. So 100 million stars worth of mass in this black hole. And typically, these things we see them at the centers of galaxies, potentially with the seeds of that lead to galaxy formation left over. Although a lot of them have been found at very high redshifts, which means not long after the universe formed. But that's where we typically see them. But the authors of this study were studying a galaxy, a distant galaxy, and they observed what you would call a bow shock feature. So some severely heated gas that just upon visual inspection looks like the gas is being heated due to something passing through it at a really high speed. And so a detailed analysis of this bow shock figured out. So not only is something traveling through this gaseous medium at a high speed, but it's also very massive, like 10 million solar masses worth of mass. But there's nothing visible there in emitting visible light. And so they've predicted that it's a supermassive black hole traveling through this gaseous medium. And so you might be wondering, well, how would that even get there if these things are supposed to hang out in the centers of galaxies? How do you have one flying through a galaxy? And they've actually, before this observation, runaway supermassive black holes were predicted whenever two galaxies, or potentially when two galaxies merge, which is actually what's going on in this galaxy that these observations were done. It's actually two galaxies in the process of merging. And so if one galaxy, Galaxy 1, had a supermassive black hole at its center, and Galaxy 2 had a supermassive black hole at its center, as these two things merge, you get a supermassive black hole merger. And that merger event would emit significantly strong gravitational waves. And unless that emission of gravitational waves was perfectly spherically symmetric, which there's no reason to believe it would be, you get this kind of recoil wave that's going to push the supermassive black hole out in one direction. And so what the authors think they've observed or suggested they've observed is just that these two galaxies have merged. There's a supermassive black hole merger, and that was a violent event that really shot the SMBH out in one direction. And we're currently seeing it leave its galaxy. And so that's what creates this bow shock feature. So it's really neat, potentially the first observation ever. And again, just piling on to all the weird exoplanets we're finding, we're also just finding weird galaxies, weird properties, and weird black holes. I even think there was a um, the an observation of an isolated free roaming black hole with nothing, no binary star, nothing attached to it, traveling nearby to not well, relatively nearby in astronomy terms. So we're finding all these cool things. It's really exciting.
all the kind of weird and wonderful.
right? Yeah.
But
That's,
it's like I said, so if it sheds out gravity waves, would they have found any evidence of it on LIGO?
I guess it depends. I don't think the authors, I don't think they, not that I saw, predicted how long ago it would have happened. Um, so I mean, it's a redshift of near one.
Okay, so it's a
So there's a good chance the merger happened ages ago, and they would have long passed by before LIGO came.
before this, yeah.
That's my guess. That's my guess.
Yeah.
But I
No,
don't have.
I just wondered if it maybe picked something up, but if it's that high a redshift, it's too far away
Yeah, yeah,
to that's kind of cool though.
yeah. Right. I mean, it's I mean, I don't know what the predict. So it's too far away. Like LIGO's mostly measuring like black hole mergers in our vicinity, but a super massive black hole merger, it's got to emit some serious waves.
You'd rather be a long way away.
Yes, that's a good point.
You'd rather be
You
a
know what?
long way away.
I don't really want that
So,
happening. Well, what do we got? 5 billion years till Andromeda collides with us.
yeah, I don't know. But it's like I said, but what actually happens out of that kind of collision? It could have, they could sort of semi-merge and then pull apart and then nothing really happens. But
Yeah,
yeah, it's really hard to predict.
yeah, yeah. It could be really boring, or it could cause a recoil supermassive black hole fly through the galaxy.
Hopefully in a different direction.
Hopefully in a different direction. Yeah, but I don't think we got to worry about it. 5 billion years,
Yeah.
they can worry about it.
Yeah, someone else can worry about it.
Someone else can worry about it.
Someone else can worry about that one. But yeah, but it's like I said, it's interesting how when you get all the speculation, the kind of fodder it makes for sci-fi
Right.
and what might come next. Because if you look at a lot of the great sci-fi, whether it's Arthur C. Clarke or Heinlein or Asimov or some of the Ben Bova, it's if you when you look at it, they're really drawing on some of the science and the exploration, some of the speculative stuff at their time. So they really do reflect the science of the time. Um, so
Yeah.
it's interesting to wonder what'll come out of some of this.
And even going farther back than that, I think I mentioned this on this podcast before, but even like Shakespeare worked a lot of astronomy into his work. Even not just the astronomy of the time, but it also seemed like he was kind of up to date on astronomy. So stuff that wasn't necessarily public knowledge, but at the academic level, he was aware of some of those findings. So it's kind of fun to even think about what his work might be like if he knew about exoplanets and supermassive black hole runaways and stuff, Like, I think the
Yeah,
most complex thing he had in his work was like a star appearing in the sky, but I don't think they knew it was a supernova at the time.
yeah. It's like I said, I guess if you think of the time that he's working, this is when astronomy is really getting going, and short in that time period, Galileo also starts doing
Yeah,
his observations and stuff. So yeah, I mean, it's like I said, it's interesting how the science affects the fiction
yeah,
at the time. And it's like you wonder how some of these like wild exoplanets or supermassive black holes and everything will start to appear in some of the sci-fi of the era, or do we are we just not producing much of that genre right now?
yeah, yeah. It's hard to say, and I don't know how you are with these things, but I can really turn my astronomer brain off and just I can just enjoy a good sci-fi, and I don't
Oh
stress
yeah.
about how accurate it is or not. I'm just if it's well written, I'm happy to listen or read or watch. But
Yeah.
I'm not the person that looks at the night sky and says this wasn't done correctly given the time and date.
Oh no. Oh
You,
no.
you
Oh,
need to.
I get irritated when authors can't even seem to figure out what the lunar cycle is, and then they talk about, you know, the full moon rising in the middle of the night. And I'm like, no, no, no. No, no, at least know that much,
Yeah.
like, yeah, like understand a bit about the lunar cycle before you start doing all this stuff.
Yeah, yeah, I could get hung up on that, but I'm not going to get too upset if they misunderstand Hawking radiation and black
No.
hole
But it's like
evaporation
I said,
rays.
that's why I guess I always appreciated like some of the Star Trek because they actually had like people advising them to make their science at least sound believable.
Yeah,
So,
they have some consultants that just, it's in the realm of possibility of what they're talking about.
yeah.
Yeah.
So I think we're coming to the end of our time,
Oh yeah.
because we're right almost at 10 o'clock. So thank you for listening. You have been listening to York Universe, the podcast by the student, staff, faculty, alumni, and friends of York University. Uh, we appreciate your listening this evening. You can follow us on our website, yorku.ca/science/observatory, to learn more about the observatory and the work we do, or to find links to all of our past podcasts. Okay? So we hope we have enjoyed the podcast for this evening. You have been listening to myself, Mary Helen Armour, and Jeremy Webb. And we wish you a good evening and a wonderful holiday break, and happy solstice.
Thanks, everyone.